So what I mean by that is, and I'm going to erase this after I'm done with it. If I were to draw, let's say, a line here and a line here, and those lines do not meet in my picture, correct? Do these meet? Do they touch?
No.
No. But if you were to extend them, would they? Yeah, these are not parallel lines. So when I say that they never meet, I'm assuming that you understand that they go forever and they never meet. My teacher used to say that they're like railroad tracks. Have you ever heard that before? Like the two lines on the railroad tracks, no matter what, are not going to cross. Okay, they're always staying that same distance apart. So you can think of it as railroad tracks. Why are we studying it right now? Well, the reason we're studying it right now is because we're talking about slope, right?
Yeah.
So algebraically, how do we know if two lines are parallel? If they have the same slope. So today, that's how we're going to check if two things are parallel or not. We're going to check out their slopes. So we're going to go back to slope again. All right, perpendicular lines. Perpendicular lines are lines that intersect at a 90-degree angle or a right angle. So a lot of times when you guys get to geometry, for instance, you might see a little square here. Did you ever see that last year in pre-algebra? That's an indicator that that's a 90-degree angle. Okay. Also, sometimes if you're not sure, some teachers will put little arrows in the middle of these. And if you see those little arrows, that's just a teacher's way of indicating that you can be sure that those are parallel. Okay, now perpendicular is a little bit different. Algebraically, how do we know if two lines are perpendicular? Okay, so I'm going to tell you the real definition, and then I'm going to tell you what it means. We can tell if the product of their slopes equals -1. We can tell if the product of their slopes equals -1. Well, how in the world am I going to do that? What's the word product mean? Yeah, so meaning if you would take their slopes and you would multiply them together, you should get a -1. Well, how am I going to be able to figure that out then? It actually means that two things. So let's explain this a little further. This one might make more sense. What does this mean? Number one, it means that they have to have opposite signs. So if one is positive, the opposite would be negative. One is negative, the opposite would be positive. Gavin, you're writing this down? Number two, these things both have to be true, by the way, not just one of them. They also have to be, and reciprocals. Reciprocals are 1 over, or flipping the fraction, okay? So the reciprocal of 2 is 1 over 2. What's the reciprocal of 2/3? Anyone know? Zach? 3/2. So reciprocals are flipping the numerator and denominator around. Okay, so let's practice. What are negative reciprocals or opposite reciprocals? Let's fill it in. So if I gave you 3/4, a perpendicular line would be a slope of negative, because this one's positive, 4 over 3. Two. By the way, 2 is the same as 2 over 1. This is positive. So would negative what do you think about this one? It's already negative. So what would this be? Positive, and then 8 over 6. Weird. 1. 1 is a weird one. Because 1 is 1 over 1. What happens when you flip 1 over 1? So this is 1 or 1. What? No, it's
like negative 0.
Can you divide by 0?
Yes.
No. So 0 and undefined.
Why can't it be negative 0?
Okay. Here's what I'm getting at. A slope of 0 is a horizontal line. A slope that's undefined is a vertical line. Aren't verticals and horizontals perpendicular to each other? They form a 90-degree angle. Yeah. Okay, so for today's lesson, we're going to do two things. We are, number one, we're going to figure out using the ordered pairs and the slope formulas, what their slopes are, and compare them. We're going to do 2 examples like that. And then we're going to do 2 examples where I give you the lines equations, and we find their slopes. All right, here we go. Number 1, my question is, are they parallel, perpendicular, or neither? So basically, maybe this happens, but maybe neither of those things happen. Isn't it possible that lines just intersect? Yeah, they don't form a 90-degree angle. So it's possible we're going to get slopes that are not these 2 things. Let's do AB. I'm going to do 6 minus 3 and 2 minus a negative 2, but what do I write? 2 plus 2. So the slope of AB is 3 over 4. This is AB. All right, let's do CD. So I'm going to do 3 minus 0, 3 minus a negative 1. What do we get? 3 over 4. Okay. What kinds of lines are these? Are these parallel, perpendicular, or neither? Parallel because they have the same slope. Okay. All right, should we do another one? All right, here we go. 4 minus 2, 5 minus 0. What do we get? 2/5. This is the slope of AB. All right, 3 minus 8, 3 minus 1. What do we get on top? Negative 5 over 2. Definitely not the same slope, right? Are they negative reciprocals or opposite reciprocals? Well, let's check the sign. Is one positive and one negative? Yes. So that part. Are they reciprocals of each other? Yes. And if you would multiply them together, you would get negative 1. That's another way you can tell. Okay? These are perpendicular. Okay. Are you guys understanding this? Okay, so let's say we were going along and we did a problem and we got a slope. I'm not saying that we do this. Let's say we got a slope of 2/3 and 3/2. Okay? Say I got that. What would you say for that one? You would say perpendicular. Why not perpendicular? Yes. So be careful that make sure that they're both opposites and reciprocals. This would be a neither for that. They meet and they at some point, but all right. Cool. We understanding? Let's go to the next. You know how I like like highlighters. So if you're given something and it's in slope-intercept form already, it is super duper easy to find if they're parallel, perpendicular, or easy, or neither. You just check the slope. 7, let's do a different color. It's just cause. 7 and 7. What do you think? Parallel, perpendicular, or neither? They have the same slope, Gavin.
Yeah. Oh, parallel.
Parallel. Same slope. Okay. Let's do this one. And that. Somebody said perpendicular. Now, if I ask you to your reason why, you can say opposite reciprocals or show me 4 times 5, or 4 over 5 times negative 5 over 4 is negative 20 over 20, which is negative 1. You can just multiply them together to get a negative 1. How about that and this? Neither. They're just opposites, right? Yeah. Let me show you how to do one. If it's not in slope-intercept form. Okay, let's look at, I don't care. You want to do 13 or 14, Kaden? Yeah. Okay, let's do 14. So if they're not in slope-intercept form, we're going to just rearrange them and then look at their slope. So it's one extra step. So what would I do first on this one? Hello? To me? Hi. Okay. Yeah, I'm just meeting with my AP kids every day. We just do a Google Meet. The kids who are here, we just do a Google Meet and we're just all doing the same stuff. Just because it's easier with those books. Have you been, I mean, I don't know because I don't know. What about, are we for sure? Okay. Okay. Well, that's kind of dumb if we're going to do it that way. Here's the thing. Never mind. Doesn't matter. It's a done deal. Okay. Have we talked about doing because Thanksgiving week? Oh yeah, we talked about this, but I know. Okay, because if we're gonna do it Thanksgiving week anyways, do you know what I mean? Then it seems like, I don't know. Who knows what the right thing is? So. Okay. Yep. Yeah, I think that'd probably be good. All right, thanks. Bye. Okay, sorry. Did you follow what I was doing?
Yeah.
Do you understand how I got a slope of 3?
Yes, I think.
Okay. All right, now I subtract 12x. I get negative 4y equals negative 12x plus 4. I really don't even have to finish this whole thing. I just got to check the slope, guys. What's the slope of this line? 3. Okay, so the y-intercept doesn't tell me a whole lot yet, except I know if the y-intercept is different. So, you know, sometimes we have these special ones, which we'll talk about later. What kind are these? Parallel. Okay. Here we go. This is what we're doing. This is a little fun thing we're going to do for our opener tomorrow where you get to actually color. When was the last time you got to color in class?
Like 2 days ago.
Oh. Your homework, which you are working on right now, is page 13. I will be walking around to check page 9? 9. So I will be around to check your page 9, which was last night's homework. But you are working on page 13.